Hello everybody, we're back with another video. Today we're going to be covering Tropical Low 11U or Invest 91S tagged by the JTWC. Let's get straight into it. I want to first go over the current structure and the rapid development that's happened. And the current evolution that was previously expected by the models wasn't exactly this. It was a case of 90S or 10U, that was supposed to become the main dominant low over the course of a couple of days, which would eventually become the low, which would undergo tropical cyclogenesis and then develop into a decently strong cyclone. That was the potential. That potential has increased to a higher intensity, and we also have a different focus low that we will be observing. It's likely completed tropical cyclogenesis right now. If you can see there, that very nice spiral convective band structure that's widely prevalent here over very, very warm waters here. I'll go deeper into those things separately in not too long. I want to dive specifically now into the current structure, its current state, and how it currently looks. So, here's the current loop. New, rapid, bursting convection, initially disorganized, but later we're going to see some nice organizing convection. I'm looking at the wrong place. You guys probably saw on the corner there. Really nice, kind of persistent convection, not organised in particular, but as it moves southwards, nice curved band structure developing, nascent central dense overcast potentially here with the current rate of development that we're seeing, and the kind of evolution that we're observing on the infrared imagery here. I will go and highlight some of the things. So you got a nice convective band, and you also got nice spiral banding developing again. So initially we're seeing disorganized convection, but new convection, much better organized, curved band structure there, spiral band structure. You guys definitely saw that. Really good structure to begin with. We weren't supposed to see genesis this early. We're probably seeing this kind of genesis much quicker than usual due to the fact that we got nice coastal convergence, frictional convergence, and overall coastline pattern we can see here. This is the kind of coastline pattern that we're seeing. I might need to change to a different color. This kind of coastline pattern that we're seeing alongside flow that goes like this, and overall the broad circulation envelope, which I'll go deeper into in a second. I don't think it's that elongated, but my point is, there's a smaller circulation embedded within this larger envelope that's been managed to be tightened up by the very favourable composition of the coastline here. I'll have a better look here with, let's take a look at the model here. I want to dive deeper into this coastline shape. We see here, this is generally where it is, and ignore the low position here. I'll go into why this is inaccurate. We see this flow will be tightening up as this kind of circular rotation is, I guess, essentially forced to go in a nice circular kind of path, and then in a loop again, increasing that cyclonic vorticity and rotation, tightening up, and obviously supporting that nice convective development and subsequent tropical cyclogenesis. Now, as you may have noticed on the 200 millibar wind plot there, very nice anticyclonic flow, very broad, and I can't lie, it's a bit weak, but very obvious anticyclonic flow, and it being embedded in such an upper level anticyclone makes it very safe within a very nice enclosed space within a low shear environment. So not only do we have very nice coastal support in terms of organising the disturbance, it doesn't have to worry about any shear effects, at least not any significant shear effects, because of this broad upper level anticyclone. If any upper level divergence and outflow wants to get out, it is able to do so through this anticyclone as well, so very supportive in that regard as well. And it will overall help in the near future. This is not temporary. I think this does last for quite a bit. yeah, we can see its evolution continues while embedded within the upper level anticyclones. It's really good for long-term intensity prospects as well. It is supposed to be around for a lot. As you can see, a very high intensity is forecast by the GFSC, 959 millibars. So, yeah, it proves that there is a quite favourable environment. I'm going to go back down to the oceanic potential that we have here. Very evidently, we got 31, 32 degree waters in this kind of environment. And once again, I'm going to refer to that coastline convergence area here. Very nice for tightening up that circulation. The upper level anticyclone, which is at 200 millibars, probably in this kind of form. So it's embedded within that as well. And these waters are around, which are obviously very capable and will be especially very helpful when it gets to a higher intensity. And it will be able to benefit out of these oceanic potentials much more for higher end intensities. I want to dive into this potential a little bit more. Let's look at the tropical cyclone heat potential mean and the current actual potential that we have for a tropical cyclone development. This takes into account the depth of the waters, which is very important, especially when this becomes a larger cyclone. It will be able to take up a lot more of those waters from underneath, and it will need that. Now, thankfully, for this cyclone at least, very large pool of red waters. We're looking at 160, maybe even 180 in some of the very peak spots. So very high tropical cyclone heat potential. When it gets to a higher intensity and when it becomes a more mature cyclone, it will be managing to benefit off of this very, very nicely. Though these waters do decrease gradually as it moves away, and it does move out further west. This is the kind of track that it's supposed to take, and so, you know, as it does move westwards, we will see a decrease in its potential. Most notably, when we do cross the 110 degrees east longitude line, that's when the tropical cyclone heat potential will really start to drop. And overall, I think all of the temperatures really do. Yeah, general sea surface temperature does also decrease very remarkably. A better view does get presented on Dapia here. So this is the South Indian Ocean view. Actually, no, that's not even the right view. Yeah, much better view here. So obviously, as this cyclone moves this way, and here's the 110 line, those temperatures west of 110 degrees east really start to drop, and once they become sub 25, sub 26, you know, conditions do turn quite hostile as a result. And convective development does become limited, and that's, you know, where its short peak will end up really stalling, and it'll just go downhill from there, really. But while it does obviously develop quickly, and it does enjoy its time as a mature cyclone, intensifying pretty quickly, those waters will obviously be the reason that happens. And if it does get its structure together, and already, we could see a pretty high intensity ceiling with the limited time it has, because the environment that it has, albeit for not too great of an amount of time, it's very good regardless. There's a lot it can do with that. Further, just to back the idea of this upper level anticyclone that it's benefiting from right now, this is the atmospheric motion vectors analysed for 15Z. Really nice upper level anticyclone around, so really nice, all radial outflow that's really present around the place. Some possibly even venting into the jet here. So that's great for current situation, really. And as, once again, I'll repeat, definitely has benefited it in the tropical cyclone genesis, tropical cyclone genesis that it's undergone recently. Now, why do I say it's a tropical cyclone now? Unlike the officials, which have not actually said anything about it developing into a tropical cyclone. So, first of all, I want to make it clear and repeat again. The Bureau of Meteorology in Australia has their own classification standard for tropical cyclones. They require gales to be present in 3 out of the 4 quadrants in a circulation, or they will automatically assume that once it reaches a 3.0 FT Dvorak classification. the classifications for the American and generally global standard classification standards are much looser than that. And we're going to stick by the more kind of generally globally agreed on standards, so that would be closer to the NHC standards, for example, right, in Miami, Florida. But not even the JTWC sees this as a tropical cyclone. I don't even think they have any noted down potential for this development, really. And obviously, if we look at the current floater, wherever I had it, yeah, here. At first sight, this convective development might have you thinking, you'll see it in a minute, this convective development might have you thinking, you got these spiral bands spiraling, very nice curved band structure, possibly a nascent central dense overcast here, and this is not a tropical cyclone. Let me show you some more. This is a scatterometer pass which happened generally around 6 hours ago, and I mean pretty evidently you got these nice northerly winds, you got easterlies, westerlies, pretty strong, nice westerly convergence, evident with kind of the barb composition there. And obviously we have these nice southerlies also turning. This is a closed circulation, although not resolved very well because it's kind of small, and you can thank the kind of coastline for that, for tightening it up so much. But yeah, it's such a small circulation, it can't be resolved by the current resolution. Not even at this resolution, like overall it is small. The 25-kilometer resolution also does resolve it. It doesn't resolve it very well, although you can make it out. But it is a closed circulation, is what I'm trying to say, regardless of how you want to interpret it. And with the current convective structure, this definitely should be classified as a tropical cyclone, at least by the JTWC, because if following the BOM standards, this isn't a tropical cyclone yet, and at least they have a consistent standard, which is what I kind of like. I just think it's a bit strict. Everyone would agree with me. So this is further backing that we've probably got a nice, well, at least close to a tropical cyclone officially, and under many metrics globally, this is already a tropical cyclone, really. So if we really want it to be consistent, this should be classified by most agencies at this point. However, the JTWC doesn't have much on it, and I'll go into what the BOM has said. They have issued a forecast track map, and they do have high chance for development. So here's the latest track map. I think the next one does get issued in half an hour at the time of recording. So listen, this is the one that I'm on right now, and I'm currently looking. Do make sure you look at bom.gov.au to get the latest information. Because you know, I'm going to say there are going to be land impacts, and therefore we do have a tropical cyclone watch issued for when impacts could happen in the next few days. So make sure you keep looking at any information provided by the Bureau. Obviously keep looking, make sure you are aware of the potential threats. I'll go more into what could potentially happen through my own analysis, right? But this is the current forecast track by the BOM. They expect actual tropical cyclone formation so far at the moment on the 19th, for their standard at least, and a tropical low until then. I feel like because of the current near-term development trends that I think they've begun to probably notice, they'll probably have their own standard of classification forecast probably for the 18th, probably sooner than what's expected here. Because at this point, looking at what it's currently evolving into, I don't think this forecast is very realistic. But one thing I will note is that they do have a severe tropical cyclone forecast. This is category 3 for the 20th on the Australian scale. We're probably looking at category 2 on the Saffir-Simpson hurricane wind scale if converted to the American standard. Ish, generally. But the intensity ceiling is higher than this, and I've already discussed that the environment is quite favourable. Therefore, the GFS, for example, has a very high, so I say low pressure peak. The pressure peak that was suggested there, probably close to category 3-ish, taking into account its large size and everything into account, really. I mean, I wouldn't say this is a bad forecast. I mean, we do need to take into account some environmental limitations, including time, with the fact that they forecast a tropical cyclone formation so late. I see why they've provided only a category 3 peak on their scale. This is when it will probably start moving into cooler waters. This is hour 72, so any further than that, and 110 degrees east. So yeah, this is generally when conditions start to worsen a little bit. It's not a bad baseline kind of forecast. I do see the potential to higher, and I would personally expect higher. One thing that there is good agreement on is that obviously we've got that tropical cyclone watch in effect. It will move close to the coast here of Western Australia, so obviously we do have that watch zone extended pretty far all the way up to Ningaloo, Exmouth area, and it is expected to move close to the coast. And with the tropical cyclone development occurring simultaneously, and fairly quickly for that matter, gales will have the potential to reach the coast. So make sure you follow the tropical cyclone advice, which I think I could be able to go through it. Yeah, they have a tropical cyclone advice is issued as a result of the warnings being in effect. Take a look at this, look any other information that you need to. It's important to make sure that standard procedures followed for your household, your people, and you know, generally speaking, in an event like this where natural disasters are around, make sure you follow the latest information that have been put out by the authorities to make sure you keep yourself and your belongings safe, or your family members. Keep everyone in good shape, and do what you can, do what it takes to make sure that everything is okay. Though we're not expecting any major impacts, we're not expecting a major tropical cyclone landfall, so in that regard, nothing too severe should be coming. But some gale force effects, maybe some rainfall might be in effect, might be coming for Exmouth and the tropical cyclone watch area as the cyclone ends up passing. So we've analysed the environment in a little bit more detail, and we do understand that the environment will be quite favourable. I want to take a look at this through soundings. So we'll take a look at the soundings and take a look at what the soundings have analysed really. Actually, before I do that, I want to show you guys something important to note. So while there is a pretty strong tropical cyclone peak forecast by some of the models like the GFS for example, one thing that must be noted is the fact that this is 12Z on the model initialization. So keep in mind that it initializes a very broad low, very broad cyclonic turn-in with a bit of a notch there where the kind of main vorticity lobe is. This is where our current invest is, embedded within this broader cyclonic envelope. This broad cyclonic envelope is around, but the model doesn't initialize the fact that there's an actual closed circulation and developing tropical cyclone in this envelope where this vorticity is. This isn't just your normal standard vorticity lobe, this is your actual developing tropical cyclone there. And if we look at the 800 millibar vorticity, it doesn't really show a tropical cyclone that well. Now, I do understand that scatterometer data did pass after the initialization, but regardless, it's important to know that we don't have the latest data inputted into this model right now, into this model run. Therefore, any intensity forecasts and general, well, we know the evolution and the track. We know a strong tropical cyclone is probably coming, but any intensity forecasts should be taken very lightly. This is why I said that the Category 3 forecast on the BOM cone may be a little conservative, because it's not likely to develop at this rate. This on the model run right here, it takes around 2 days, or just under 2 days, to get itself together in a broad state that it's in. We could see this tropical cyclone interact within its broader envelope, but I feel like because we've already got a coherent vorticity, I don't think we're going to have this broad multiple vorticity lobe interaction. I don't think that's going to happen. I think we're going to straight now run for higher intensity now. I think we're going to be beginning the run to higher intensity now. We've done tropical cyclone genesis now. We're going now with straight up intensification. We're just going to continue doing our thing right away without trying to get anything together, because it's essentially got itself together now. We know it's in an envelope. I'll show you guys. Like we do have this cyclonic envelope as I described. But this coherent vorticity should just take up the whole envelope at this point. And realistically, in my view, I don't think we'll have that many problems. Because what we have here is, yeah, it obviously interacts with the whole envelope and the multiple vorticity lobes that are around, because it doesn't show the system as a coherent vortex, like it actually does exist at. This is weak. This is obviously going to be interacting, and it's going to be spinning around to try form an actual tropical cyclone on this run in just less than 2 days. But it's a tropical cyclone now. It's more than just a vortex that's presented here. So this interaction probably won't be happening. We're probably going straight intensification, and we're probably going straight for that peak right now. We're probably on that journey right now. I do think it'll get abroad, because it will have to try and engage within the whole envelope to actually... It will become the dominant vorticity in the envelope. Because it's in the envelope, it's going to have to take all of it together, really. And that's why we've got such a broad cyclone. And what's interesting is the fact that regardless of the interaction, the environment is so favourable that the GFS gets it down to such a low pressure regardless of the beginning interaction. Now that we're going ahead of schedule, and we've already got a full-fledged tropical cyclone, and a very nice coherent established vorticity lobe, that's essentially your coherent vortex now, we definitely can see a higher ceiling. Because it's already going to be benefiting with the current core structure, with the inner core structure, and the current the current development that we have right now. It's already happening. Like the main stage of intensification, where it's not like it's already organized, it's already got itself in shape. But that part's finished already. We're way ahead of schedule, so intensification is going to be quicker, starting quicker, ready going. And not only could we have a longer peak, but we could definitely have something of a much higher scale, much higher intensity. So the ceiling is high. And we could be seeing very significant overperformance compared to what the models suggest. What will be important is taking a look at the newer model runs that have taken into account the ASCAT data and seeing how they model the system afterwards. But this is only the GFS solution, so obviously we know that this is probably your upper bound, considering the evolution that happens at the beginning. Our upper bound is higher than this, naturally, overall, in reality. I want to take a look at the different solutions that we have. Obviously your European solution, it's always known for being weaker, but it does intensify it still quite a bit. It does hold that same environment. I think we all do have good agreement on the fact that we will be under a broad upper level anticyclone. And later some poleward outflow does become established. You can't see it, but overall it goes in a form that's kind of like this. So it will tap into the jet somewhat. At that point though, it crosses the 110 degrees line and sea surface temperatures will just batter it at that point. It's not going to really be helping. What I want to discuss next is the soundings, right? So we've established obviously the fail mode that kind of comes with it being a bit too broad, and well, we know it's likely going to be developing, but what will probably limit the intensity is the kind of broadness that is initially displayed. But I don't want this to be taken into account so much because we know that it's not going to evolve this way most likely. Again, even though the European model likes to underestimate or so-called under-forecast because it always gets future tropical cyclones way weaker than they actually are, that's always how the European model always has been. It's always been on the weaker side of the guidance most of the time. Uh, but yeah, this would still be way too weak, even for the European solution. Like we can see it tries to intensify quite a bit. If we look at the ensemble and the ensemble members themselves, we see that there's a lot of strong members there. I think I could probably get a better plot up of the intensities of these tropical cyclones that are developing on the ensemble, but yeah, I mean overall you can see a lot of the members like they do intensify quite a bit. They do intensify. Sorry, I can't speak. They do intensify a lot more than the deterministic counterpart that they have. Overall, this could be low even for the European standards because again we do see this evolution. It's not likely to be happening this way. Again, I do want to see the European solution and the European model at the 12Z run that will be coming out soon, and I do want to see it simulate the new scatterometer data to see how the evolution is forecast on the next run, because it could generally be more rapid, and we could. So I don't know what happened there when my video randomly cut off. What I was going to go on to next was the soundings that we have on the GFS. So while we do have a broad system, we can still apply the soundings that generally do. The location of the sounding fix is fixated on the main vorticity lobe, aka the system that we're currently looking at. Now, what I was meant to go over is the environment was favourable, or it is favourable. If we look at 18Z, which is the current time, well, 57 minutes after the time of recording, but we can generally see that while we do have 16 knots of maximum shear, generally focused on the mid-levels, we can see that if we look at the holograph first of all, and taking into account the system movement, which is generally west-southwest, southwest, we can see here with the steering. We're looking movement 9 knots. If we look at the current satellite imagery, we look at the satellite evolution, I can kind of agree. We're kind of moving maybe 9 knots, 7 knots, generally that kind of range. The exact number doesn't really matter. We're looking at mid-level flow being around, same kind of direction, first of all, same overall pattern, quadrant direction. We're looking southwest movement with the mid-level flow, sticking at around 10 knots, just under 10 knots, similar to the speed of movement that we have here. So overall, the shear vector is aligned with terms to both movement and speed. Movement direction and movement speed. So overall, the shear in this plot, and we can take a look again if we look at the max shear analysis overall, cut off the boundaries that are given there, and we can see southwesterly kind of direction of movement of the vortex, and the flow is also relatively suiting the movement direction, and the speed of the flow is also aligned to the steering that we have here. So the initial environment is pretty clear. With that upper level anticyclone, I think it was pretty clear we do have quite a nice environment anyway, but I wanted to dive into the specifics of a current sounding analysis to just give you guys a bit of a more in-depth idea of the current shear environment and the flow, the vertical flow of what we currently have, where the vortex is. And this environment doesn't really change. If anything, it might get slightly better at times, but the overall flow at times is aligned, is good, it is very suitable for intensification. As you see, these barbs all aligned, and the shear vector overall, in both terms of speed and direction, they align with the system, they align with the vortex, and the overall shear dynamics that we have analysed on the soundings, they do suggest that the environment is very favourable. And I think it being embedded within an upper level anticyclone does give that away initially at first sight. So we can see very favourable environment in most metrics. Time is the only factor, but it's getting itself together. I do think we're going to see a very nice peak intensity within the next few days. And I did say, like, we are probably going to see a much higher intensity compared to the GFS, just simply based off the initial evolution. I think the other models will catch up when they assimilate that data that ends up from the scatterometer. They'll assimilate that data for the 12C runs or the next run, depending on the run that we have. Let's take a look at the ECMWF soundings. I think I'm just going to do a quick, nice kind of run through without much depth. The flow does seem to be slightly stronger and actually slightly more variable. That could contribute to why the ECM doesn't actually have that high of an intensity, but nonetheless it does intensify quite significantly to a kind of category 1 range cyclone. Which for its evolution stage, its kind of development stage at the beginning, I thought that's pretty good. It does suggest that with everything considered now, we definitely could see a much higher intensity than this, and that's what the GFS shows. If the GFS analysis environment does end up verifying, and the GFS environment, that's all overall forecast, if that all verifies, again, as I said, definitely could see a very high intensity cyclone because the environment is just very favourable, and it definitely aligns with some of the historical upper end cyclones that we do see in this region. Very favourable environment. It would be a good chance now to reach a high intensity, I would certainly say. Now, because we do see some kind of increased shear on these soundings, looking at it, like doing a brief run through with the soundings on the European model, this would probably be attributed to the kind of to the alignment of the up-level anticyclone, its general composition over the Indian Ocean and on Australia, really. Because I think I did do a run through this, but it didn't capture it. And we do see that, yes, at the beginning, the broad upper-level anticyclone, first day or so, it's embedded within the broad upper anticyclonic flow, so it's generally decent. But then the kind of core centre of the upper-level anticyclone is more focused over the Pilbara area and Western Australia, we see. So this flow, particularly strong easterly flow, is impinging onto the cyclone somewhat. Though within the broad flow, it's embedded within still, and the kind of flow could appear to still be divergent, especially if it taps into the west side of that upper level anticyclone. That flow might go a bit more poleward and benefits it. So like it does do here, that flow could go back up, and it does actually have some equator wood outflow as well, as we can see some flow goes a bit to the north as well. But yeah, main focus, it is a little bit more displaced from the core of the from the upper level anticyclone, the centre. It's a bit more displaced compared to the GFS solution, and that's fine. I wouldn't say this environment isn't absolutely like a catastrophe or anything. Under this environment, we could still definitely get a pretty good, decent intensity, despite what the European model solution is. Because again, I stress, it's all because of the initial development phase where it has to interact with multiple vortices really, within one big envelope, and it struggles to get itself together initially before it has limited time to do anything. So, I think I've rambled on enough about the kind of environment and the evolution that the kind of models are presenting. But key facts to take away from this video is we have a pretty full-fledged tropical cyclone. Again, I mean, I didn't actually show this earlier, but we see this nice curved band structure that's kind of evident, which does suggest a developing tropical cyclone, like I've said many times, and also does help support the idea of what we've seen on infrared convection satellite here, with all this spiral banding developing. Though my initial concerns now, looking at this a bit later, I see the central convections fading. I do wonder when it does come back, and I do hope that we do see, in terms of its structural prospects, I do hope some of that outer banding does subside so inner convection can actually get going. But yeah, now going back to some of the old microwave imagery, we do have a tropical cyclone structure there. once again suggesting that the models do heavily have this poorly initialized, but I am awaiting for the next runs to see if some of the data from the scatterometer does get taken in, assimilated, and we get a better representation on the models of not only the potential intensity, but the current environment as well, see what's analysed. That's all from me. Key things I don't think I actually got on to finish that. Wait for the models, wait for new runs, keep looking at model trends. Definitely for people living on the coast there, make sure that you are safe, you follow any local advice. Some strong winds are likely as the cyclone passes by. It will have quite a big influence because of the large cyclonic envelope that the vortex is embedded in, will be developing inside of. So large threat of winds, or so I say broad threat of winds. As you can see, pretty strong barbs going over the coast there. Evolution on the models is too slow. Do not take it at face value. We have a much more developed cyclone than what is shown here. So do wait for the new runs, wait for the new data, wait for the new outputs. Definitely monitor new developments to see how this convective structure evolves, because it could deteriorate a bit initially, especially with how much banding is developing here. This amount of banding could actually appear to be quite unhealthy. So definitely see how the structure evolves. This might be part of broadening the system as part of its broader envelope. So this might be part of why its structure might later on be kind of big. This could limit intensification. We don't know. The current favourable environment could suggest that. The very favourable environment, I should say, might actually be able to help it with this regard. It's not marginal or anything. It's quite a favourable environment. We could see this large system develop pretty comfortably, despite what what is possible with some larger systems, which do take quite a while to develop at times. We should be fine here in terms of intensity prospects. I would forecast a high intensity scenario here. We're looking at major tropical cyclone status on the Saffir-Simpson hurricane wind scale, and my upper bound on the Australian scale could probably be around category 4-ish. This environment, I repeat, quite favourable, so there is quite a decent ceiling, I would say. Thank you all for watching. I've rambled on and off too much in this video. We did have a problem midway through. I've added 2 clips together, which go over the most important bits, and I'll keep you guys updated on the evolution of this tropical low, which has a significant chance to develop pretty well over the next few days. Thanks for watching, guys. That's all from me, and yeah, I'll have more videos coming soon. Thank you.